Welcome to the session about hacking a magnetic lock, successes and failures. I'm going to talk about a bit of research I did about a certain lock, and it involves all kinds of maker space related stuff that I have been doing. And I would like to tell you not just about the successes, but also the failures, because if you do a bit of research and you are a hobbyist yourself and you try out things, then you know that things will fail. And often people won't tell about all their failures, and it's all very nice on social media and everything works the first time around, but that's not really reality. So I'd like to go through my process of hacking a particular lock and also explain you the fails. Now I have 108 slides, so one, I'm going to talk fast. Two, probably for questions, I will be in the lockpicking stand later on. And let's see if I still have enough time to go through all of them. So I'm a lockpicker, and I happen to have some locks around that are made by Japanese firm Miwa, but they're also made and sold by Anker, which is here in Enschede, as the Anker 3800 series. And I have one of these here, so you can have a look and pass the lock around. So I had this, and I'm a hacker, so I want to know how stuff works, and I decided to spend some time on this. Now, it's not very weird that I'm looking into a lock, because, as I said, I'm a lock picker. I've been president of the Open Organization of Lock Pickers for a while. I've been involved in lock picking since 1997. And I recently wrote a book about lock picking as well. Okay, but enough about me. Let's talk about this lock cylinder. And if you open it up and look on the insides, you will find all kinds of stuff in there. You will find pins, but you will also find some stuff here on the top. And what makes this lock interesting is that it has magnets. If you look at the key, you can already see that there are on the top these 8 black blobs, and those can be magnets. And on the bottom, you have a bitting like you will find on an ordinary key. It can be a magnet, each blob, but it can also be a fake. There are also black blobs that do nothing. Now, and how does that work in the cylinder? Well, the magnets, if you take out the plug from the top part and put it here, you'll see that there are sliders, 4 of them, in the plug that go back and forth. And these sliders have magnets, and they operate on the magnets in the key. So if you insert the key, then the magnets will make these sliders go left-right. And they need to align. I'll show it in more detail later. And then we also have these 4 pins on the bottom. And the pins, to me, is not really that spectacular, because this works just like any regular lock you will find. I mean, it's still interesting. You could go to the lockpicking booth to have a go at picking a lock with just such pins. But this is something that we have known about for a long time. So the pins are quite standard, but these magnets are what make it interesting. So here I've taken these sliders out of the plug, and I laid them on top of the magnets in the key. So you can see that there is a pair of magnets, 4 pairs, that operate each one slider that can slide up and down in this position. Now, to make it even more clear, I did some photoshopping. So this is my first achievement, bad photoshopping. And here you see the lock without a key. And you see that there are pins, and the lock will only open if the pin is pushed down to the shear line. And here you see the correct key in the lock, and you see that the pin is free here, and the plug needs to rotate in the end. But we also have the magnet, and here you see the yellow slider with a little spring, and the slider needs to be pulled in. And if it is pulled in, then it's also free here to rotate. So to open the lock, we need to push the pins to the right position, and we need to slide the sliders to the correct position. And that is where the magnet in the key works with the magnet in the slider to move it to the correct position. And you also see I've drawn a fake magnet here that does nothing. If you take a key and you lay it on top of magnetic paper, you can see where the magnetism is. And you can actually see that of each pair, there is only one that is a magnet and the other one is fake in this case. Because for each slider, we only need to have 1 magnet. And you also notice that these 2 are one blob and these are 2, and that is because the magnet can be in different positions. This magnet is facing that way, but this magnet is facing that way, north, south. And that needs to match the slider to get them to the correct position. Now, if I insert, so I've taken the plug out of the key, out of the lock, and if I insert the wrong key, then you will see that the pins are not correct at the correct depth, and the sliders are sticking out. So this key will not work. This will not operate. And if I insert the correct key, then all the pins are perfectly aligned, and all the sliders are also perfectly aligned. And then you can open the lock. Right, so I hope this is clear, very brief introduction on how this works. And I started to think about security of this lock cylinder. And for the 4 pins that are in there, you can use traditional techniques such as lockpicking. Now, you also need to move these sliders, and you could put a little magnet on top of a toothpick-like device and move it inside the lock and move these sliders. You could even use audio amplification, so you hear maybe little clicks of these sliders going back and forth. But when I started this research, and this is already a number of years ago, I had never seen anybody pick this lock, although in the meantime, yes, people have picked the lock, and I've picked it also myself. It is not easy, I have to say. So it's a lot of work, but if you really put your effort in it, it is possible to do so. But I don't think this is a real world issue you would need to worry about. So what I initially thought was, well, what kind of issues do we have with locks? Because people talk about having a secure lock, but what does that mean, a secure lock? Are you afraid that somebody will break it off your door? Then you need to have a very sturdy lock. Or are you afraid that if you lend out your key to somebody, they can easily make a duplicate? That's another risk. Or are you afraid for the Secret Service doing lockpicking? So depending on your risk, you need to have special stuff in the lock to prevent that risk. So one of the risks is key duplication. You lend your key to somebody and they can easily make a duplicate. So I first tried to look into that. And I made a test cylinder, and on one side I only have pins, and the other side I only have magnetic sliders to do my tests on. And I thought, well, how do I duplicate a key? So for that, I need to duplicate the bitting for the pins, and I need to duplicate the magnets. So I need to know what magnets are in the key. So I need to have a device that measures magnets. In comes the magnetometer. So I just Googled for a magnetometer, and I found a schematic. And I also like doing electronics, so I thought, this is nice. Let's build this. And then you have a special chip, a Hall sensor, that can detect the magnetic field and a bit of electronics. And you can make a LED turn on. So, achievement unlocked, I created a magnetometer. So that's a little Hall sensor device that can measure the magnetic field. And I hold it over the magnets, and it will show me with the LEDs what it is. And you also notice I go left-right, because some magnets are in the left-right orientation and some are in the up-down orientation. But if I have read the magnets, I still need to, if I want to duplicate, I need to create a new key. How? Now here's the problem. This system is quite old. It was invented it was patented in the 1980s. So the patents have expired, so there is no legal reason why you could not create a blank key. A blank key is a key that needs to be cut in the shop to fit your specific lock. But these are not to be obtained, because there is no market for it. Nobody makes these blank keys, because if you would make them, nobody has the equipment to do anything with them. The only place in the Netherlands where you can get keys is at the factory themselves. They have the keys and they can make them for you at a price. So then I thought, well, what I can do is I can make a setup key for the magnet. So I'll make a key that holds the magnets, and then I do lockpicking for the pins. Let's see if that will work. So I dremeled an existing key with the idea we can replace the magnets, and then we can do the picking. Now this was a failure. There is so little room there for a lockpick that if I insert the lockpick, then it will already push down all the pins too far. So this way, there's no way I can open the lock. But I thought, well, let's just assume that it will work. can I actually exchange these magnets? So I bought some cheap 2x2x2 millimeter magnets, and I needed to take an existing key and make holes for the magnets to put in. And here you can see another failure. My metal work is not as good as it could be. And I completely butchered this key, and there's no way I can get the correct magnets in. Okay. Still, I was on this track of I need to have a setup key, and I can't do picking. So can we also copy the bitting? So let's park this magnet problem for now and focus on the bitting. Can we copy that? Now with lockpicking, there are ways of with regular keys, there are ways of copying the key by using molding techniques. So you have two-component putty. You put the key in there in a little device. You take out the key. There's a nice mold of the key, and you pour in special metal, and you have a copy of the key. That actually works. So can we do that with this key? So I made a mold of an existing key, and I combined it with my special setup key. So my idea was, we have a setup key with the magnets, and I will just I will pour in with metal the bitting for the pins. And so this is those two keys combined. And it does work on my special cylinder with only the pins. Right? So the pin copying did work. But I still had the problem with the magnets. So yeah, making a skeleton key from an existing key, I could not really do because of my metal working skills. And also these magnets are 2x2x2 millimeter that I used, and the key, and that leaves very little room because the key is only a little bit thicker than the magnets I used. So that makes it very hard. And I thought, well, maybe the only thing that I could do this is by using 3D printing, but I didn't have a 3D printer. But this was just before COVID, and then COVID came, and I had time, and I had a little bit of money still in my pocket, so I decided to continue and buy a 3D printer. And I thought I need to have a printer that really prints at a very high resolution, so I bought a resin printer, which is really a pain because of all the chemicals and stuff. And you need a curing device as well, with a UV light to cure your printed stuff. And I didn't really think this through. I just continued with the goal I had set before, which was to create a setup key for the magnets and a slit for picking. So I was still on that track, and I created a 3D model. So another achievement unlocked using OpenSCAD to create a model. And this was my first design, and I printed it, and I was lucky that it printed correctly almost the first try. So I needed to file it a little bit, but it worked quite well. And that was good because otherwise I might have become so frustrated that I would have abandoned the project. Because 3D printing, if you have experience, sometimes it works, sometimes it doesn't. And really, it's also quite a bit of work to calibrate everything correctly. But I was lucky; it worked, and it worked on my special cylinder with just the magnets. And this is a later iteration where it printed immediately correct to be inserted into the lock. Now later I found out, because there are these videos about lockpicking, I found out that if you pick the lock, then at first it's the pins that block the cylinder. So if you pick the 4 pins, it will rotate a little bit, and then you need to get the sliders in the correct position. So there is an order to it. Pins first, then magnets. So then I thought, aha, but if you do pins first, then I can pick the pins in this way, and then I have room, because I come in from the side instead of on top. So I have room to pick the 4 pins. And once the 4 pins are picked, I'll insert my special key with the magnets in there, and that will set the sliders, and then the lock will open. Now I tried it, and it did work. I have to say, again, it was quite hard even to pick these pins. There are only 4 pins. Most locks have 5. But these were still, for some reason, I don't know why exactly, it was hard to pick. So, what can we achieve now? When you have temporary access to the key, you can use my magnetometer to read out the magnets. You can print a setup key and pick the 4 pins and open the lock. But of course, if we are 3D printing the key, why not print the bitting in the same go? Obvious. So I changed the model again to include the bitting. So you can just type into the OpenSCAD code what kind of bitting you would like to have, and now it flips to another bitting. It flips to another bitting. So you can just create keys that you would like to have, and they look something like this. And yes, that also works. So this was achievement unlocked. Proof of concept, we can print a working key from an original key. So that's one attack vector. I borrow your key, your high security key, and I make a copy using the magnetometer and the bitting. Actually, the bitting, I didn't tell you before, but there's only 4 discrete depths for each pin. And that is not much. Many locks have 7 or 9 positions, but this one only has 4 positions. And if you give me a key from Anker, I've seen so many of them now, if you give me the key, I can see with the naked eye exactly what the combination is. So if I have your key for 10 seconds, 20 seconds, I can measure the magnets, I can look at the code, write it down, and I can make a copy. The keys I printed on my resin printer were, though, very brittle. I later learned that there's quite a difference in resin that you use, and there's also a resin that is much more stronger than the one I used first time. But this one, if I would drop it from here, it would break in pieces, and that's not really good. If you use this in a lock, it will probably also break. And I was discussing this with a friend of mine, and he said, well, I also have a 3D printer, but it's a FDR printer. What's it called? Filament printer. I can try and print a key for you as well. And I thought it wouldn't work because of the tolerances, but actually it did work. So he printed a key made out of plastic, and it worked. And some other improvements are, instead of using the 2x2x2 millimeter magnets, I try to use smaller magnets. I did order 1x1x1, but they are so tiny, there's no way you can handle those. If you take tweezers and try to put them in the key, they will turn around because of the magnetic field, and it's hopeless. So I settled for these one. These are discus magnets, 2x1 millimeter, and that means that depending on the orientation of the magnetic field, they either lie flat or they lie on their side in the key. But still, there is enough room. And of course, because we're 3D printing, we can just print the holes to match the orientation of the magnet. And another improvement is that places where there is no magnet, we leave out the hole to make the key more sturdy. Yeah, so you can have a look at the key. But let's take it a step further. We looked at copying the key. But what if we don't have a key to start with? Is there anything we can do if we are just facing a door with a cylinder and we don't have the key? Well, these magnets can be facing up, can be facing down, or north to the left or north to the right. Those are the only 4 possibilities, and the blank, of course. And the orientation of the magnet in the slider always matches the orientation of the magnet in the key. There's a 1-to-1 relation. If I know the orientation of the magnet in the key, I know exactly what the orientation of the magnet in the slider is. They must match. Otherwise, it doesn't slide to the correct position. That also means that if I know the orientation of the magnet in the cylinder, I know what the magnet in the key should be. In a Anker lock, there's always 2 sliders that slide to the right and 2 sliders that slide to the left. That's just the way the factory makes them. So that's a given. And suppose I have a key with these magnets to operate on the sliders, then I know that these must be the magnets in the sliders, because that's the only way in which they are pushed to the correct position. So let's read out the magnets from the cylinder. So I took my magnetometer and I tried to read them out, but this was another fail because the sensor is too big and it doesn't fit. The keyway is so small that I cannot put my sensor in. So I did some investigation and I found that there are smaller sensors out there. I put this onto my magnetometer, but it didn't work because of voltage levels. Anyway, I also needed to make a little stick thingy on which to put the sensor. So I tried to design a little PCB. And I was told by somebody that you can just print out the PCB with a laser printer on inkjet paper and then use a iron to transfer it to the PCB. But that didn't work. I don't know why. Maybe I did something wrong. So in the end, I just used a Sharpie. So this was a fail. In the end, I just used a Sharpie and etched it. I etched it a little bit too long, but it still works. And this is a 0.4 millimeter PCB, so very thin. Put the sensor on top. So etching was a achievement, but still it didn't fit. So the only way of getting it to fit was to not have the sensor on the end of the PCB, but to glue it at the end, not on top, but at the end of the PCB. And this was the hardest of the whole project, was to solder this thing on the PCB. And I used a magnifier with a 0.1 millimeter wire, and that was really horrible to get that together. But in the end, it was a success. But as I said, it failed because my original magnetometer worked with different voltage levels of the other sensor. So this sensor didn't work, so I needed to build a new magnetometer. And I thought, well, let's use an Arduino. I didn't want to use an Arduino because an Arduino is like as fast as an old school 83, 86 computer, and that's a bit much processing power just to light an LED. But I did it anyway. So I built this Arduino where you can just insert this in the lock, and I need to wiggle it a little bit to see if the magnet is facing left, right, or up, down. But this works quite well actually, and so you see I made markings to know where the sliders are in the lock, and I can just go past them and read out all the magnets. So then I thought, well, let's go all the way, and I made one with a touchscreen, SD card, software to decode, to automatically go from what you read in a key to what is in the cylinder, or vice versa. So here I can just read the key. So there are a lot of fakes. Here there is a real magnet. It's facing, it's red to green. So I typed that in the cylinder. I found a red-green, and it will translate for me. That means that in the key there should be a red. So red is maybe north and green is south. So I guess that's the actual cylinder I gave to you. So this was fun. This was a bit of programming on the Arduino. It wasn't too complicated. And now I can see on the key that I read exactly what the program has said it should be. And I can save it to the SD card. So with this, if I have temporary access to a cylinder but I don't have the key, I can still read out the magnets from the cylinder, and I know exactly what magnets should be in the key. I can create a setup key with the correct magnets, but I still need to do something with those pins. So I either need to lockpick it, which was hard, as I said, or you could maybe print 256 keys, because it's only 4 pins with 4 possibilities. So if you print 256 keys and put all the magnets in all 256 of them, one of the keys will work. It's not really a real-world attack, I think. So do we have any alternatives to lock picking to open a lock? Do we have any alternatives? Braking. Yeah, impressioning. Yeah, but there's also bumping. Bumping is a technique where you smash a key that has too high bitting in the lock, and this will make all the pins get a shock, and you get this effect where the energy is transferred, and there will be the picture is not really true, but you will get a gap between them, and in a fraction of a second, they will separate and you can open the lock. And it is not as easy as it looks, because you need to have the timing exactly right. But I thought, let's give it a go. I can now print the keys on the other printer that makes more sturdy keys. So I created a key from plastic, and with the incorrect bitting, so it doesn't operate, but by bumping. And of course, in this movie, I took the movie where it works in one go. But normally it will take maybe 6 steps or so. So it's still very, very effectively.
When you practice, right?
Yeah, well, I've done bumping on other keys as well. So if I give you this in your hand, you've never bumped before, then it might still will take some time. So this is nice. So impressioning, somebody said. So that is that you take a blank key and you wiggle it in the lock. It will make tiny marks, and you file away a little bit of material until it fits. It's really nice that we have competitions in that as well. So can we do that? So here's a key I filed in the French lockpicking championships a few years ago. They gave me a blank key, and I wiggle it, and where it makes a mark, I file away. You see, I filed away on places where normally it doesn't need to be filed away, but it doesn't matter as long as the place where the pins drop, it has the correct depth, it will work. But to do this on Anker, I need to have a blank Anker key, and I told you I can't get them. So I have a colleague who had a small CNC milling machine in his home, and he said, I'll make you a key. So he made, well, this is one out of aluminum that he did for a test, but later he made one from brass. And so this key, you can wiggle, and you will see tiny marks where the pin is going too far up, and you file away a little bit, and you try again, and try again, try again. And then, so I filed away here, that's not needed, but it's about these spots. They need to be in the correct depth. And in the end, it did work. But again, it was very, very, very hard. I've done a lot of impressioning, also competitions, and this was really high-level impressioning stuff. So it is an attack vector. If you have temporarily access to the cylinder, you can read out the magnets using my magnetometer, and you can either create a setup key and bump it, or you can create a blank key and do impressioning, but really, really hard. Now, I still have 38 slides left, so what I will be talking about next is the fact that we also have often master keying in these locks. So these locks were sold to big institutions, banks, hospitals, where they normally need master keying. And master keying is that you have cylinders that have their own key, but you also have a master key that will open all the cylinders. And you can have several levels of that, but we'll focus here on the setup where we have a few rooms. So maybe you are in an office, and you have an office, and your neighbor has an office, and you both have a lock with their own key, and they don't go in the other office, but there's somebody walking around who has the master key, and they can open both doors. That's master keying system. Traditionally, you can buy master keying in standard locks. So this is a standard pin terminal lock. And how that normally works is that they cut the pin in half. And that gives you, on this pin, two possibilities to get the pin to the correct depth. Now, here we have Alice and Andy. They have their own lock. And if Alice tries her key in her lock, it works. But if Alice tries her key in Andy's lock, you see this pin and this pin, they are not correct. So this will not open Andy's lock. So Alice's key only works on Alice's lock. This is the key. Andy has its own key, which works on Andy's lock, but it doesn't work on Alice's lock. This one and this one is not correct. Right, so Andy and Alice both have a key that operates their own lock, but we can also create a master key, and the master key will work on both locks. So this is how standard master keying works. And what you see here is Alice's and Andy's lock, and you see that the master key has a different bitting in those two positions. Now the trick is that normally the master key has more material. You see that this is higher than the other keys. Anybody know why that might be? The reason is that if you are Alice and you have a file, you could file, and it would be the other way around. You could file a little bit, and then you have suddenly a master key, and they don't want that. So to get from a normal key to the master key, you need to add material, and the idea is that you cannot. If you, let's see what I'm going to say now. So if I am Alice and I want to know what the master key is, here's what you can do. You can get some keys that are, if you can get blank keys, you can get a blank key and cut them exactly the same as your own, except for the first pin. You print it in the higher positions, and you try out those two keys, and maybe both of them don't fit. Then you create new keys, and you copy these positions, but the second one, you have a 6, and you try depth 1, 2, 3, 4, and 5. And you try out all these 5 keys, and maybe that one fits. So then you have learned that if you change this from a 6 into a 4, it will also work. So you know, that must be in the master key. And you do the same for the third one. It doesn't fit. The fourth one, you will find that it doesn't fit. And the fifth one, and you will find that this one fits. So then you know, the master key must be this one, because we found this alternative depth, and here we found that alternative depth. So this actually you can do if you live in a apartment complex with a master key and shared rooms and individual keys. You could do this trick to get the master key, although that would be unethical. Now with the magnets, it's really much more interesting. The magnets you can also master key, and that is why the magnets come in pairs. You can have a magnet on one side, or you can have a magnet on the other side. And so far we've seen that there were only magnets on one of the two sides, and the other one was a fake. But you can have master keying in the magnets. How does that work? Suppose I'm in an office, I have my own key, and I know what magnets are in my key. So I also know what must be in the cylinder, otherwise my key wouldn't work. But now I'm going to take my device and I'm going to measure the cylinder. And if I measure the cylinder, I want to get to the master, but let's measure the cylinder. And if I measure the cylinder, I see these green ones because they need to be there, but I also see a few additional magnets, right? And if I see those, I know, this is because of master keying. Anker does not just put magnets in there just for fun. If they are there for a reason. The reason being is that there must be another key that uses this magnet. So if there is one other key that operates on my cylinder, the master key, then it must be that the master key has those. So what I've learned from this is the following. The master key will need to open my lock. And to open these middle two sliders, it must have a south here and a north there, just like my key. So I'm sure that these are in the master key. These blue ones are not used by my key, so they are there for the master key. So the master key must have the corresponding magnets in the key. So the master key must have these magnets. Okay, what else do we know? What do we do with the slider with two magnets? Should we put in that magnet as well? No? Well, I can show you by example. So this is my key. Let's suppose I have a neighbor that also has a key. And you can see that this one has north, south, and south, and this one has south, north, and north. So you see key A does not fit this lock, and key B does not fit this lock. Now, if I put in the second magnet that I found on my key, then this master key would work on this lock, but not on the other lock. So indeed, if I find on my key a double magnet, and I don't know if I need to put that one in. But if I go to my neighbor's door and read out their magnets, I will have learned more. I will have learned, here it is an N, there it is an S. So in the master key, there must be nothing fake. Also, because I read the neighbor's door, I find here a N, which is new. So first of all, this one is the same here. So it could be that I have to put a magnet in here, and it could be that I don't have to. I don't have enough information yet. I don't know what needs to be there. This one has a north here, but I haven't seen the key, so I don't know what I need to put here. If I... Whoops. So I learned a little bit, but still I have a few question marks. But the idea is that the more cylinders I read out using my magnetometer, the more information I get, and at one point it will be absolutely clear this is the configuration of the magnets in the master key. So that's interesting. So with this device we can, with enough time and enough logs to inspect, we can figure out the magnets in the master key. But we still have the pins as well. And they can also be master keyed, just as in the way I explained before, which is that you cut the pin into two halves. It's now laying on its side. So we have two possible depths for that key, for that pin. So you have length 1, 2, 3, 4, and you have spacers 1, 2, 3 to make all possible combinations. And this whole story that I told you before, we can just go from the top and go deeper to find other spacings. It doesn't work for this lock, because this lock also has the magnets. If you find another, you don't have to make sure that the master key has more material, because the master key can also have the magnets in a different position. So you can file away what you like, but you will never be able to change the magnets to the correct ones. So that's a really nice thing about this system. Now, it might now be a little bit overwhelming, all this information, so let me give you an example of how this would work in reality. And for that, I got from a friend a number of cylinders that came from a Dutch bank that they who changed their cylinders. It's 5 cylinders, and I did not have any key at all. So how to get them open? And this was a master keyed system as well. They almost always are. So I started with a table with all the cylinders and the keys and the master key, and I started measuring with my measuring device. And I measured all the magnets in all the cylinders. And this will give me information. I see, for instance, that the middle two sliders, they are the same for every cylinder. So I know what magnets need to be there. Also, I see that here it says RG, and here it says GR. So this magnet cannot be in the master key, whereas this has RR. So that one is of the master key. So with this I can conclude what the master key should look like. Well, actually, those two I don't know, because I don't have more than these 5 cylinders, and in these 5 it's all the same. But now the bitting. So we need to have a start. I need to be able to open a lock oh wait, before that I can also determine what the key for each of these cylinders must be, because if this is the master key and this has a magnet here, then the other magnet in the lock must be for the other key, for the key that only does this lock. So the key for this lock only needs to have a G here and not the master key magnet. Yeah. Now I was lucky that I had one half cylinder. And why is that lucky? Because the half cylinder I can open using bumping. Because I knew the magnets, I could create a bump key. I bumped it open, and the half cylinder I can disassemble and reassemble again to a working lock. With the double ones I can't, but with a half one I can. I took out all the pins, and then I can just look at the pins and measure how deep they are, and I know exactly what is in this lock. And the first pin could have a depth of 3 or 4, and the second pin 1 or 3, and then 2 or 3, and then a 4. Still, I don't know. So I have 2 times 2 times 2 times 1 is 8 possibilities for the master key. And I don't know which one is the master key. But of course, I can just, 8 is not that much, I can just create 8 keys with all the 8 possibilities and try them out in all of the locks. And by doing so, I found out that this is the master key combination. So I'm now done. I have the master key for these 5 cylinders. Now I wanted to continue and figure out what the single-use keys are for all these cylinders. So what I did is I took the master key and I made keys where I only changed the first, the second, the third, or the fourth bitting. And with that you can just try, is there also a 1 or a 2 or a 4 in this position in any of the locks? So I created 12 keys. Or actually I printed 4 and then I used an X-Acto knife to go to cut it one deeper. And I was able to go past all cylinders and check all the possible pin positions. And just as with the magnets, I now know if there is a 4 in the master key, and this has a depth of 3 or 4, then the 3 must be there for a reason. It must be there because it's in the end user key. So with this, you can create all the keys. So I printed 5 keys and the master key to the whole system, and they all work without ever having seen the master key. The master key, of course, in gold. So for this, if you want to get a master key, what you will need to have is one key to start with. If you don't have a first key to operate a lock, it becomes difficult. You can maybe bump it, but then you don't know what the pins are inside. So if you have at least one key, that will get you a start. Or you need to disassemble a cylinder, but as I said, then it needs to be a half cylinder, otherwise you cannot, you can open a double one, but then it's ruined. You can decode the pins using a number of keys, depending on how the configuration is. So in my example, it was 8 keys, but it could be more, it could be less. And then for each new cylinder, you can keep on measuring the magnets and getting more information about the magnet in the master key. And your key gets better and better. So it's a success because this allows you to create a master key in the system, but it's also a bit of a failure because it's not just you work on one cylinder, you do a bit of work, and then you have the master key. No, you need to go through the whole facility, look at all the cylinders, and the more you look at, and depends on the setup, how many you need to see before you can be absolutely sure this is the master key. So it's possible, it's harder than anticipated, and the reason for that is that this system has both the pins and the magnets. So for people who are more visually, here's a visual summary. So in the start, if you have a key, then you can decode the magnets of the key. You can decode the bitting with the naked eye, and you can make a duplicate using your 3D printer, which is nice. If you don't have the key, you can at least decode the magnets in the cylinder. And then there are a few ways of going about. You could try to create 256 keys, and one will work, or at least one will work, but it's quite hard, that's why it's light blue. You can make a setup key and pick it, but that's also very hard. You can do impressioning, which is very hard, or you can make a bump key and bump it open. If you impression, you have a working key. If you bump or make a setup key and pick it, then you have opened it at least once. What you then can do maybe is open the cylinder, look at the pins, and then you know exactly what's in there, and that also gives you a working key. Now, if it is master keyed, you can decode the possible master key bittings using a number of keys that you print. Then you have an idea of what the master key might look like, and you can improve on that master key by doing additional decoding in other cylinders and find other bittings in other cylinders. And the more you do this, the better your key becomes, and you get the master key in the end. So with the advent of 3D printers, conclusion, almost all vendors actually have to deal with people copying keys using a printer. So this is becoming really a problem because manufacturers have for the last 20, 30 years relied on the fact that you need to have a special card to get keys duplicated. But now you can just make a 3D model and print it. So that's really becoming a problem, and it's quite hard to protect against. The good thing about this is that you also have the magnets, which make it very hard or harder to print. But yeah, the downside is that the magnets, they are readable from the outside of the lock. So finding the grand master key still requires some work, more than with conventional locks. So that's actually a plus because this is quite an old system, as I said. The patent has already expired. It's from the 80s. It is not being sold for new buildings, but it's still in use quite a few places in the Netherlands and beyond. But still, the security level is quite good. What I'm saying here is quite difficult to do. Please don't test this on cylinders that are not yours or are in use, because if your key breaks in the cylinder and it's in use, that would be an issue. And what's also nice to say is that before I gave this presentation, I went to the factory, the Anker factory here in Enschede, and I contacted them to say that I had done this research and what they thought about it, and if they want to have a look at the slides before I presented them. And I was met with the head of R&D there, and I had a nice chat with the person. Of course, they knew about these kinds of attacks. I mean, this is not secret stuff. Lock companies know about this. It's just that this cylinder is already quite old. They are still providing cylinders for people who have the system, but they do not do any research on changing that lock. They have other locks that they work on, but not this one. And they were nice enough even to supply me with some of these blank keys that are otherwise unobtainium. So I do have some blank keys for those. And thank you for being here and watching this presentation. And I hope this might be a little bit inspiring for you to keep on hacking, do interesting stuff with electronics, with 3D printers. And if it doesn't work the first try, don't give up. That's also part of the process. Thanks. Ooh, I spoke so fast I did it in 45 minutes. So we may even have time for questions, and otherwise I will be here for a while at the lockpicking booth where you can ask questions or maybe look at some of the stuff that I've made. Yes. Oh, you get a mic for the recording.
Yeah, I'm just curious how long this process took you to finalize.
Well, this is not something I do for a living, right? So it's just sometimes I work on it for an hour or so. But I think in total it has took me 2 years, but not continuously. But but it's also getting a 3D printer, figuring out which 3D printer do I need, setting it up, figuring out what kind of resin you need to have. It's a lot of small things that you need to look at. So it's quite a lengthy process.
Did you also consider maybe electronically manipulating the magnetic slides by maybe including a coil in your 3D print?
Yes, I thought about that. I thought about some improvements, like also making a device that reads all the magnets in one go, or maybe a key that indeed has coils that can do it, or maybe even combined, where you read it and automatically set it to the right magnets. But I did not make it because it would be too fiddly. So I did look into Hall sensors that can do 3D sensing and that are small enough to be put on a PCB to insert. But that already I ran into problems with this stuff uses SPI or I2C, and I don't have enough place for all the traces. And I thought, well, I'm not going to make this in a professional product, right? There are people who work in this industry, in the industry of figuring out how to circumvent locks that build devices that are sold to, I don't know, intelligence agencies that sell for a lot of money. But for me, it's just a hobby. I'm not interested in selling expensive equipment. And creating that with the coils would be such a leap in terms of fabrication that I didn't even start.
Okay, thanks.
I saw that on the keys there's also a code. Did you ever think, you did think about this, but
there is a code, but the code is the number of the system as Anker sold them. So if Anker sells a new system to a vendor, there's a code stamped on the cylinders and on the keys that matches. But it doesn't say anything about the bitting or the colligation of the magnets. It's just a sequential code in time. So I did look at some facilities where you can see, this is a newer lock and this is older, and with the numbers. But other than that, no.
Okay, thank you.
Okay, that's it. Thanks.